welcome back. We're here today to continue from yesterday. Let me get the chat stream window, I mean. Okay, cool. Starting to share the screen. So this one, let's do this. And Miguel has joined. Hello, Miguel. How are you? Hope you're doing good. Whoop. Here we go. My picture goes here. And is the sound okay, Miguel? Can you please let me know? Also, I'll try to turn on the music, the background music. Hopefully it won't be too loud. Yesterday it wasn't, so I hope, yeah. So everything cool. Okay. So let's get into our back into our work, right? So I'm going to grab a terminal and let's go into our folder. It was simple Docker, right? So increasing font size, repo view -- web, and from here I'm expecting to see. Okay, let me git tag episode 1, right? And git push with tags, and hopefully enough people can come and find the episode. So that will be cool. What else? I want to open the Notion guide. So hang on just a second more. And we'll put our hands on deck or on dock. On Docker, right? So starting the container for such app, and still need to take care of this for this was episode 1, and we also did the publish container ports on host, and today we're going through episode 2, right? Cool. So let me stop everything. I think I have things running. Index with timestamps. Yep. Thank you, Miguel. Yeah, I will take care of that and update YouTube description and make a blog post with all the episodes all in one post. So yeah, that's my idea. If you have any suggestions for make it better, I'm all ears. Okay, let's head back, and what we've been doing, we can do docker ps, and I need to open the project again. Open recent, simple docker, here we go. There we go. So yeah, we've seen few commands we can run. Sorry, excuse me. So we can list running commands, we can build an image, we can run that image, and we get as a result a container running with that image. We can stop the container, and we started seeing we could publish ports from the host machine to the container. So we mapped first from 3000 in the host that would go inside to the container to 3000, And also we mapped from 80 to 3000. So let's do it again, just for a quick recap. And there we go. We'll map port 80 and container is listening on 3000, but we mapped the 80 from the host to 3000 on the container. So what we can expect to see is localhost 80, right? Whoop. Will point to the container that is running. So this is cool. So what more can we do? We've seen the input, yeah. So I think a next sensible step, now that we have one application running, we'll see about volumes and files. So for instance, if we want to map persistence to the container, I'm going to try and find yeah. So if we want some persistence, because containers, we can run many, and let's see how these, what I mean by running many and why I'm giving this context. Oh, look, Cristóbal has joined. Hello, Cristóbal. Hope you're doing good. Thanks for joining. What are we going to do? We are going to run a container from this, right? From this image, and we're going to do docker ps, and we see we have one container running, but of course, I will stop it. And now it's not running, but we'll see that it was running. You can see there were even two containers running, because when we've done docker run, it started a new instance of a new image. So each time we will run, it will start a new one. So it's like if this is a machine. Let me get back to good notes. So yeah, for the case being, we add this case, right? Copy. So yeah, we were having two containers running. Of course, we would not be able to map both at the same time, because this would give a conflict. But let's say we could put port 80 to this container, 3000 to that one, and this would still work, just like two virtual machines inside one computer, one host computer. So this is one fact, this is true, and this is to give you context, right? And something that we can also do, of course, is to bring back another container. So we can also do come back. Whoop, no. Docker container and start that container, and now it started detached, right? So we rebooted that container. So even with we're not having the output is working. Okay, we are getting the response. We can see here 11 milliseconds, 20, and so on. So hey, Francisco also joined. Hello. How are you today, man? Glad you could join. So we are running it again, right? So if we do, we are one of that containers is still up again. So we can reboot another container or restart, but also we can stop it, right? BCD, and now it's stopped. We can see that by docker ps. And something also we can do is to delete them all. So docker rm bcd and docker rm 6ce, and sure enough, if we were to run this again, we don't have them anymore. And so these were deleted, but of course we can bring another instance of these back because we are running one image of simple docker, right? So what we want to explore now is the persistence layer. And what we want to do, or what we'll do exactly in this matter, just deleting this, okay. Maybe it's easier with a pencil for now. What we're going to do, I want to make this more open. So this is the container, and we are going to map one folder, right, of my hard drive into the container. So this folder will be living at the same time inside the container and also inside my hard drive. So this means that each time the container is destroyed, the folders will still persist. So yeah, we're going to do just that. Okay, and please remind me if possible. So quick recap and start persistence volumes. So yeah, I'm gonna make these kind of markers so that we can make chapters. And okay, that's cool. So let's this time run again a container and let's map some folder inside. So I want to open this folder where I am, and let me do like this. Okay, easier. Okay, so let's make a new folder, and it's going to be called I don't know, storage or some files. It's irrelevant. It's to delete. It's not a problem. I don't know if it's easier on the Finder or on the console. We'll see. I regretted doing it, bringing another stuff. So yeah, we have the files folder, and what we're going to do is we're going to run that container again. Let's check below if is there anything running. There is not. So docker run, and we will map the port 80, and now we'll also map a volume that it will be the current working directory slash files, right? And this is in my host machine, and I want to map it into inside the container, like, I don't know, slash storage, for example, or yeah, let's call it like this, storage files. So it's running, and I've mapped that folder, right? So inside the container, what lives here in this folder will live also inside. And how will we find that? we will go inside the container in a minute. So let's run a container and also map a folder to inside the container, right? Okay. And this is cool. So something else we will learn right now is we have a running container and we have this ID and we want to go inside. We want to get a shell. I don't remember if we've done it last time. I think not. So what we will do is to go to a bash session inside the container. So I want to be in this world, right? It's like SSHing, similar on the storytelling world. It's like SSHing into the machine. So let's do that, and we'll do that by a docker exec this time, and we want to be interactive, and we will run on that image 41128 the command bash, right? And there we go. We are the root user in that host, and I can show you pwd, and we are in /app, our working directory. And of course we're running Ubuntu, not macOS. And sure enough, if we now go to that folder /storage, we can see, whoops, ll does not exist, so ls, and we have that folder files that would not exist before, but now that we mapped, it does exist. So it's empty, right? But let's see some kind of magic. And we have the folder right there. And we are going to just create a file and say hello. And as you can see, it also appeared in my machine, right? And if I were to copy this, I can now ls and see that we have the copy file that we have just made, right? So yeah, this is the first approach to the volumes. And what does this mean? It means that we can remove the container. Let's get back to the chart, not chart, but diagram. We can delete the container, and again, when we will bring it back up, the folder will still be there and it will mount again. So yeah, this is for the first approach for the volumes. So this is a bind mount, and we have mapped one folder, and we can do that also with files also. So we will see it will be very typical to mount just a .env file, for instance, in another environment. And we have a question from Miguel. He's asking, can the volumes be configured in Dockerfile? And the answer is almost no. I mean, it's like no, because that would be a security breach. If, for example, I would make one image with one Docker file that would mount your hard drive into inside my container, you would run that from a public repository, and the source code that I would put in my container would have access to the whole disk. So that is not a desired behavior. What can be done, and I don't remember this exactly, is you can publish things that are in the container. Yeah, Miguel is saying it makes sense. Yeah, nice. Um, what we can do is to expose. I don't remember exactly how, but we can imagine you have one file or one folder inside your container, and you want to inform Docker that you would like to put it outside. So yeah, it can generate it for you, but never from the system to the container, but the other way around, yes, because that would not be a security concern. So Docker file, expose a folder. How to mount? I want it from Docker. It's not. I don't know it from out of my head, but I will find it from another project. I remember. So Docker file volume. I don't remember right now. Let me try to find. I think it was in Directus. One project here that I saw exposing a folder like this, and nope. Not. Is there more Docker images? Yeah, maybe it was here. Let me try to check. Yes, exactly. So Miguel and everyone, of course, we can do in the Docker file. We might say this folder from the container. I want it to be a volume, so it's like the container taking the responsibility for its persistence. So it's like it's going to create a folder the outside system, but never the other way around. Okay. So let's get back to where we were, and have we did we find this? I think so, right? We can do hello. We did some files. Yeah. So we can just do the quick exercise of stopping the container, right? It threw me out. No problem, Miguel. Just any questions, let them come, yeah? From everyone, like the questions that you may have, other people will have. So I'm glad to answer anything I can, for sure. Even if it's just your question, I don't care. If it's a question, I want to address it, right? Cool. So I want to delete the container, right? So Docker rm 4112. Okay, we deleted it, right? Docker ps, nothing, with a simple image, right? So if I were to go to the directory, we can see it's still there in my machine, right? So if we were to run again, Docker run a new, totally new instance, right? So now it's just a fresh installed container. If we were to go inside, Docker exec, inside 748, I want to run the bash command, and because it's interactive, it will give me the session. And now, sure enough, if I will do storage files, I can see the files again. So yeah, this is the first approach for the volumes bind mount. So there is a folder in the host machine and it will live inside the container. So right now we'll see the next volume I want to show you. The next kind of volume I want to show you. So, whoops, not this color. So Command Z, this color, and this is the boundaries of our host machine, right? And we might have or Docker as from natively. Sorry for the bad typing. Okay. So Docker also manages Docker volumes, right? And it's a native feature. We can do Docker volume ls. And of course, let's pretend it's, whoop, I'm inside the container. Docker volume ls. I want to see always restricted to simple Docker, right? So let's say there are no volumes right now, but what we can do is to declare a Docker volume, right? And it might be called whatever, right? It's just a string and it will be simple files, for instance. And this Docker volume is managed by Docker himself. So we don't have to care about the location of the folder, and it's very simple to just reference it from a string. It's handy, for instance, in databases, for example, MySQL and so on. There are many files that we exactly don't care about to see them from the top level host machine, and other cases. So we will see now this second case where we have a Docker volume and we are also going to mount it and reuse it. And of course, we can reuse these volumes even with other containers, right? But this is for a future episode. Yeah, let's do this. So we have Sebastian Perez. Hello, Sebastian. So he's saying, few days ago I made a Frankenstein mounting a NFS as volume, so Sonar can download and move file in my series folder. Yeah, we can do some twist stuff. The power and flexibility of the tool is amazing. Yeah, that's cool. Okay, so let's share this with the container and reuse it. Okay, so what we're going to do is to stop and let's make, oh, we need to create the volume first. So Docker volume create and simple files, we called it, right? And we have now we have one volume called simple files. So it's this, it's just one name and it's a folder that Docker reserves for it. So again, we are, oh, sorry. Let me put the mark. Oh, I didn't put the timestamps, but at least the chapters will be easy for later. So start persistence, bind mount volumes, and I don't know how to call this, but Docker volumes, Docker managed volumes, so like native, and this is at around 30 minutes. Cool. So we have just created the simple files, right? Right. And now we want to run the container once again. Nothing is running, we'll see, right? And we want to run our simple application with the volume simple files. Notice that it's just a string, it's not a path. If we were to do this, this would be a path, right? Starts with slash or dot slash something, and it's always a path. But if you reference just a string, it's a native Docker volume. And let's keep it simple, but later on, if you want to mount a volume just on the other way, just read only or with different permissions, we can. But for the sake of simplicity, let's keep it like this. Just want you to know. Maybe you're thinking about not letting a container change files, just read them, okay? But for now, let's mount the empty volume into storage inside the container slash, and what's more, let's call it more files, yeah? And it will create that folder inside the container and simple Docker latest, right? Let me copy this. So Docker run, oh, I'm missing SSH into, it's not SSH technically, but start a bash or shell, start a shell session inside the container. So we'll go with that in a minute. So right now let's put it multi-line and let's do it like this. Yeah, so what we'll do now is to also mount a Docker volume to inside. I think to inside is redundant to say, yeah. We also need to create it first, right? Volume, create simple files. Okay, we have some more questions, just stopping for a moment. So Sebastian is saying, I was forced to move to Docker because in my Pop! OS installation for some reason I can't install PHP 8.1, and also I have a few other projects that need another version, so for me was helpful. Oh yeah, totally. I can see. It's wonderful because it's very light compared to a virtual machine, right? And even you are being in Pop! OS is Linux, right? A cool, very cool distribution, and you can. It's very light, and you can have multiple environments, everything isolated and stored in the repository. Revisioned is great. Yeah, glad you enjoyed it. I love Docker. And I like to see other people enjoying. So there is also, Sebastian is saying there is a way that you can create an instance of each service. I mean, one for PHP, one for MySQL, one for Apache or Nginx, and use it as your dev environment without create a container for each. Yeah, so you can do both. And we will see that in our series because definitely I'm going to cover a few frameworks and examples, and one of them will be Laravel, my framework of choice, and we will be able to, you can check right now before I even get there, but you can see Laravel Sail. So it's the native default first party development environment with Docker that Laravel ships with, and I wanted to show you. You can see it in the docs, of course, and also github.com/laravel/sile. And what happens is we will see that, let's check a runtime, PHP 8.1 that you wanted. It's the same, but I will open Docker file and this other file, supervisor D. There's a high chance that you know this, you being a Ubuntu user already. So what we can see is that Sail and other systems, you don't have to do one single process per container. Of course, for certain use cases, that's the way to go. But for another simple use cases, the one process can be supervisor. We cannot see it right here explicitly, but if we go to start container, we'll see that this is because we might run commands from outside. It's a helper from Laravel. It's very cool. We'll check it later. So if no commands are given, the entry point will run supervisor, right? And this supervisor, right now, it's running a program that is artisan serve, but you can add more, right? And I can even show you something I've been doing. It's in my blog. So the very simple approach, the simplest approach, is very similar to Sail. So you can come to this article and you will see that there is a package you can use. I don't know if you're a Laravel user. Are you, Sebastian? Even so, this works for any PHP because, yeah, that's a bummer because PHP doesn't have an internal web server. So we have to use a web server and FPM, for example. So let's look at this GitHub. Whoop. So github.com/ in this package, I'll show you all. So it's something that you can install if you are using Laravel and very quickly have a setup for production in a very simple manner. And stubs, I guess, production within a single container. And I don't know if you are, maybe I'm getting ahead of time, but you will see that we just have one service, right? But what matters is there is just one process in the container, which is supervisor, but then it forks a few spawns, so a few processes more. So we can see there is just one single container and we're running Nginx and FPM and cron just under one container. And for the most simple website, it's more than enough, right? Even some medium load, it depends on the context, on the project, but this is perfectly fine. There are more authors doing the same, and I've used this for lots of time in production in multiple companies, and not a problem until today. Of course, you will find some problems if you need from a certain load, or it depends on what your application does, but major use cases, I would say this is perfectly fine. What we can also do, I'll try, no, but we'll get into there. It's also very easy to put 2 or 3 or more containers. I've done it in the repository is also open source. Maybe let me try to find it. So it was Inspire. I made this app for a talk that I gave a few weeks ago and a few days ago, and you can see that here in this file, what I hope you know Composer, or oh, you use Laravel often, cool. So just to finish, and let's get back to the basic stuff. If you know this Docker Compose already, so that's cool, you can go ahead. And then the problem with Artisan Serve is that you can't use htaccess, right? For rewrites or something that you want to do, I don't know exactly, but totally, you can use Nginx and FPM locally, no problem. We will find the way how to do it, but you can see that it's very easy. For instance, this is one container that is like an extra compose thing. So we are putting a reference to this object, right? And I use it multiple times. So I can use all these as a web server and mapping the ports 80, for instance. And I can use the same container and run another thing, right? So I could scale this Inspire worker to more processes. So yeah, that's it. This would also be very easy to use with two separate services. So it's up to you if you want to use separate services or one service supervisor that has multiple forks, right? Cool. So let's get back. I hope I was clear enough. If not, we will come to this ground again for sure. Yeah, check the repo. Let me know. Leave some issues, open an issue on the repo if you want to ask something, or Twitter, comment on the video. You know where to find me. Please let me know some feedback. And Samuel has joined. Hello, hello, Samuel. Welcome back. Thank you for joining again. Yeah, no problem, Sebastian. My pleasure to help. My pleasure. Cool that you find it useful. Okay, so coming back, we were going to mount a volume, right? Yeah, let me find the command. It's here. So let's mount a Docker volume that we have just created, and let's first create it, right? First have it created, then you can use it. Cool. Very straightforward, right? Let me copy from here just to make sure everything will work later on. So pasting, and it started running, and now we have one volume, simple files, mounted into this folder. But now I don't have it in my folder where I ran the command. I don't have it exposed, right? I don't have it here, for example. Docker is taking care of that for me, but we will see that it's working. We will assess that it's working. So let's run into the container. So this is the ID running. So Docker exec interactive container b86 and bash. Cool. So we can go to /storage ls, and sure enough, whoop, we have the more files folder, right? Because we have done that here. And this is the native Docker volume, right? And yeah, this is inside the container. Cool. So let's go to more files. It's empty. Whoops, it's empty. So let's make a file. Do I have nano? Nope. So I want to touch. I was here. I was here.txt. Whoop. I will try to edit with V. Oh, still don't have it, right? Something we can do also is to just run commands, because this is a container from that base operating system. So I guess we are okay to run commands, right? And later on, we will also see how we can commit these commands, this state of the machine, if we want to do it not in a Docker file, but from a running instance. So I updated, so let's install nano, my choice. Okay, so now I can nano I was here. I was really here. Yeah. There we go. We have one file with this content. And that's it. I'm just gonna stop the container. And I'm gonna remove every container of this image. So docker rm b86. It was exactly where we created the file, if you remember. And I also want to delete 748. And I will take the opportunity to show you one flag. We can, when we run a command, and delete the created container after exit. So this is like great for one-off commands. Okay, so we can do just docker run --rm, right? So we could, now that we're going to run again, also let's add --rm, and next time it will stop, it will delete itself. So docker ps grep simple, no containers. I will now run the above command, mounting again the docker volume, the native one, into that folder, or I could even do it to a different folder. It's for the sake of sanity, I will not change it, but yeah, we can do whatever. It's a volume and it's safe within docker managed folders. So I will just run again the same command. So if I were to run again, same command, new container. So docker exec, interactively 7f, and I want to run bash. So I can show the directories of storage, more files, and sure enough, I have I was here file again. So I'm gonna show the output, and of course, it's the same file. The location is possible to know. I don't know exactly where it is, but it's out of scope. If you want to find it, it will be in /var, I don't know, some kind of folders, but it's just that Docker is managing it for us. It takes us the responsibility of defining stuff, and that can be good, and that can be awesome when we will look at the next set of commands, not commands, but to the next chapter, yeah, because we're going to look at Docker Compose, and that's going to be huge. Okay, we are already doing this scenario. Just to recap, we have a container running, right? And we can mount a folder from our directory that we want to define, or we can also have a Docker native container native volume created and mount it to whatever folder that we also want. So yeah, I think this calls it for right here, and we will start with let's explore Docker Compose. And what's Docker Compose? Uh, I don't know if this is the official definition, but it most likely is from there. But what it means is that we can make compositions, yeah? So if we want to make one container or two containers, let's say one app and one database, we would need to run one command like docker run MySQL, for example. This is pseudocode, of course, and docker run my application and so on. So this would be lots of work to type or to manage in script files and whatnot. So we can make compositions of infrastructure and commands that we want to run in a convenient Docker compose file. And it's now native inside Docker distribution. I'm not exactly which one, but this is to say that sometimes you might see me using docker dash compose and other times without the dash. It might have or not this dash when we run it, but it's we're speaking about the same stuff, and we can find it. So where are the docs? Typically, I come from Google, right? So docker compose docs, yeah, and we are into compose. So yeah, Compose is a tool for defining and running multi-container Docker applications. But even so, I like to have a Compose even if I just have one command, because I can persist the commands that I want to run in a YAML file. So that's why it's so convenient, right? And then with a single command from Compose, you can do multiple stuff. So you can create and start all the services from your configuration just in one command. Start, stop, rebuild services and whatnot. So if you want to go through the docs, you should. But of course, let's do it in a simple way and grow from simple into complex, and we'll make that journey easy. Or that's what I'm trying to do. Let me know how I'm doing. We have 10 more minutes. So for today, let's just say explore Docker Compose, right? The command is all lowercase, but it doesn't matter. So today we have seen volumes. Yeah, I think I said everything that is for now. For the start, this is okay. So what are we going to do? We're going to do a file, a YAML file, and it's called docker compose.yaml. Okay, and inside this docker compose YAML, so we have it here, and because the standard file is this name, I mean, if you have a file with exactly this name, Docker Compose will grab it and interpret it, right? So we can just run docker compose. It's the command. I will close the below session, and we can do just like if we run just docker. We didn't go through all of the stuff, but you can and you should with time. And with docker compose, we will also start simple. So what we will be using will be, for example, we can use build, and we can use start, stop, up to create, to start services, of course, when after they're stopped. And how are we going to do that? So as a first, let me guide you from the docs, because I don't so install, yeah, I don't want to tell you something wrong. So docker compose file, YAML file, right? Compose file specification, yeah. And I want to find, there we go. Okay. So first things first, we have to explain to Docker which version of the API we are using to the commands. And we have a table of the versions that we can use, but for the sake of this tutorial, let's just use the latest and we'll go from there, and we'll do exactly, we can copy it or do one by hand, but no, I don't think so. Let's just copy, no need to make my by hand, right? So I will just delete this and leave this. So yeah, first things first. If I remember correctly, let's go from top. And first thing we've done, of course, to run a container, we built an image from our Docker file. If you're watching this for the first time, be sure to check the first episode. You will understand everything. So we want to build this, but not to having to memorize all the stuff and manage bash files and whatnot. We can do this. How? We can give a name to the image. So let's call it simple Docker. And let's use it like this. And I don't want /dir. I want to run the build command. That composer will help me to issue the command with the context directory where it's running, the current directory. And I want to use a Docker file called Dockerfile. I'm being explicit here. I believe it's the default, and the only thing you have to say explicitly is context. I'm used to have it because sometimes there are multiple Docker files depending on the environment, but this is the default. I will leave it right now. So what we can do now is Docker compose, and the first time let's run config, okay? And what did this command do? It went to load all the configuration that it could get from the arguments that I gave him. It means no arguments, right? And because I gave no arguments, it defaulted to find a docker compose.yaml file, and he interpreted it and got this configuration. So there is a service called web app, and to build we will use this context, this folder, the dot, right? We will use this Docker file. It will create the image with the name and tag simple Docker latest. Docker compose, he will explicitly declare that there is one network, and it will create it for us. We didn't see that. We didn't have the need because we just mapped ports to the host machine, right? But there will be a day in a future lesson or live session or class, I don't know how to call it. There will be multiple containers, right? And they will have to communicate with each other, and they will do it inside. So yeah, there might be multiple networks that might be configured in many different ways. So this is why. So all I'm gonna do now is docker compose, and I will issue build. And what did it do? Notice that I just did build and it started doing everything just like before. So instead of having to issue this command, I just have to remember that I want to build, right? That's it, simple as that. And of course, if I would have more services, because I could, let's just do this for example. So let's have a second application, and let's run it again. And it would build twice, of course. It will use the same image, so it's different. Okay, so let's do this. Image 2. Imagine I would have multiple services. Docker Compose would take care of everything. So if I were to now do list the images, sure enough, I have one image simple Docker and one image simple Docker 2. So as you can see, we have everything just in one command. Hello, José. So welcome, and hope you enjoy your stay. Live from Lolé, José Borges. Okay, nice you could join. Thank you. So we will delete this for now. Just one more consideration. This file and this file, these image files, they are declared as using 800 megabytes, right? But they are, Docker is clever enough so that he uses layers and caches them. So you might have multiple tens of images that share layers. So it's possible to have theoretically 100 gigabytes of images in a 50 gigabytes hard drive if they are just a repetition. Okay, this is just small consideration, just a small side note, right? So let's delete this for now, or even leave it, and let's do something. Let's run this stuff, right? It's what we've done after, right? So before Docker Compose, we build the image and we ran it, right? So now we're going to use Docker Compose up, and from here it will start everything. And notice that we have two applications running now. You see the output of one in this blue, aqua, turquoise color, and this yellow. So they are two instances of the same application. So we are having, a repetition, 1, 2 equals, and they are both having port 3000 open, right? Cool. So next command, we are passing the 1 hour mark. So let's start finishing, but I don't want to finish before showing you the same commands in Compose. So I think 2 minutes more. Whoop. So we might stop it from running. So I will just Control C, and notice that Docker Compose is interactive by default. So I didn't need to do /ti or something. It just ran in the foreground and attached to my input, right? So I can now do up, right? And in a different folder, Docker Compose stop. Well, up, yeah. I could do stop. I could do start to restart, right? And it would restart. Also, I could Docker Compose, I think it's logs, I don't remember. Yeah. And logs dash follow, I think. And it will just not output, but continuously follow. Yeah, that's it. So if I were to go, oh, it's not mapped, so I cannot access it. I mean, I could. We can do something in our development environment. We can do Docker PS, and anything is inspectable in Docker. So we can inspect this ID, and we have output about this container. So we will be able to see its state, the image that it's running, the SHA from the image. So what else? We will see the IP address. So data, the volumes mounted and so on, environment, the reference image, labels, network settings. So yeah, this is what I'm looking for. So this is my host machine, and IP address for this container, it's this one, 0.3. So let me curl http / this IP in port 3000. Will it be able? Because I'm on, I was figuring that, yes. Oh, it's a different network. It's not attached to this network, right? So yeah, it will not be available. What happened is that Composer created a network just for the service of its own. So it's not connected to my host network. So that's why it will be for a later episode. Never mind. What we will check is that we have 2 containers running. Okay. And what else? Mounting the volumes and mapping the ports. So yeah, we stopped it. If we want to delete all the containers in just one command before changing, let's run docker compose down, and only then it will really remove everything that it manages, and in this case 2 containers and that default network. Okay, coming back to the ports, let's do that. So the first application we're going to map ports, and we are going to do 80 from the host machine into 3000 of the container. And we have to do this in form of an array, because we could, this is a syntax, YAML syntax for array. Is it saying to put quotes? Okay, it's safer. And what's more, oh, it has to be, or else it has to have quotes. What's more, nothing. We could do it differently if we would do like this, and I guess it would be comma, but it's up to you. It's just default YAML. It's very powerful markup, and you can exploit it for yourself. Cool. So now this container will be mapped from the 80 to 3000, and let's do the same for the other container, but of course this would result in a failure. So 81. Okay, and right now if we were to run again, we can inspect network, right? And sure enough, we have our ports here. You can see one container as the port 80 from the host machine and another one as 81. And both are mapping to 3000 on each container. They are a repetition of themselves. So yeah, that makes sense. So if we were to go to the browser, we can see that localhost is working again, but also 81 is working. What failed was a 5 econ, but we can see 81 is working. Yeah. So we can curl localhost 80 and we get a response, and also on 81. And now we can see the output coming. Yeah. Cool. So what else? Let's map that images, right? That folders, I mean. So we will do that with volumes, and in the left we are going to map on the left host folder, and at the right container folder. So to do the equivalent to the folder, yeah, it would be /files and to storage files, just like we did from the command. So files folder will go to storage files, and simple files will go, the native volume will go to I like it to see it as cleaner as possible. So I just use quotes really when needed. So we are mounting 2 volumes in this container. I will delete this second one. This was just for understanding. It's more clear like this for now, I think. We've seen it working, and now we come back to the simple stuff, and later on we make it complex again. Cool. So this would be a match with all of those commands. So let's just see it to work. And I will stop and up again. Whoop. Service web app refers to undefined volume. Oh, right. So what happened here? I'm going to say that I want to use a volume called simple files. And it's complaining that it's undefined volume. This is because I have to be very explicit to compose. Here I'm defining services, right? But also the things that I will use within the services, or at least a few, like the networks and volumes, for instance, we have to be very explicit what we want to use. So I want to use a volume called simple files, and like this would be enough, but this simple files project would create a volume called simple files under the namespace of this compose project. So we will see more on that later. On the next episode, this is exactly where we're going to start. I'm just going to say that this volume exists and that it is external, okay? Meaning that I will have, for me to use the other one that I previously created. So this is from a top level volumes, from the top level volumes list. And that's it. So I will up again. So it found an orphan container because there is the second service that I removed. So this is normal. And right now I just have one application running. And now I can do Docker compose. What do I want to do? I want to go inside to show you, but I want to show you Docker PS, right? So the namespace I was mentioning a few seconds ago also is valid for the container names. So this name now is using simple Docker just because it grabs the folder that we are running it, dash name of the service, right? Web app, because is named web app, and -1 because we might have multiple repetitions of this instance. So compose is clever enough to make unique identifiers for later reference. And because we are using compose right now, we can use just the service name. So you remember exec from before? We will do docker compose exec. And now in the service web app, I want to run bash. How simple is that? So right now I'm inside the container running the application. And sure enough, I can go to /volumes. Whoops, I cannot because I made, what mistake did I do? Storage, sorry. So all is good, it's just my mind is not working. Not volumes, storage, right? And I can do ls, and sure enough, I have the files content, and I have the more files content. So I am reusing everything I was using from the list of commands. So take in consideration the amount of commands that we should have to issue by ourselves. But look how simple compose makes it to us. We have a YAML file that we can store, and we can run just build, exec, run, up, down, start, stop. So that's kind of cool. So yeah, guys, thank you for being here today again. We are finished for today. We're going to continue on a next live stream, hopefully tomorrow or the next day. So I will try to make it every day, but can't promise such a high level of consistency. But that's the goal, right? So please let me know if you have any questions. Still someone watching. Don't know if you are in front of the computer or did you leave? So yeah, closing thoughts. Let's explore Docker Compose. We did everything. I don't remember the timestamp, but we converted all the commands from Docker to Docker Compose. Okay, so Sebastian is asking for the GitHub. Hello again. And of course, I can share it. So it's IJ Patricio. So I will leave it in the description, the link for that. For this, you want, I guess, which was the one? Inspire. It was where I was, right? No, it was not. So you want simple Docker, you want Inspire, and you want the one from the blog post. So I'll also share that. And it's called Docker for Forge, right? Yeah. And you also want the blog.jpat. J Patricio, it's my name. So you will find the blogs explaining the stuff, how you can use it within Laravel and Forge. Also outside of Forge. It's just that this one is ready for that service. So yeah, I will share them in the description. And of course you already see it on the screen, but I will share it in the description and soon also in a blog post. Thank you, Sebastian. Thank you also for being there, for the questions, and I hope I see you in a near future. Okay, so I think we are finishing for today. I want to thank you everyone that was here with me today and everyone watching at home. So after this recording, thank you so much. Bye bye. Bye, Sebastian. Bye, everyone. Happy coding.